My name is Conrad Quinterno, the Data Processing Manager at Phoenix, and I'll be hosting today's webinar. Phoenix LiDAR Systems specializes in building complete mapping solutions. Our products cover you throughout the whole process, from data collection with our integrated hardware to data finalization with various in-house software options. Phoenix has risen to the challenge of building many new solutions over the years that help customers achieve their individual survey goals. We understand that one size does not fit all, and we really take pride in helping to ensure that you have the right tools to create the data that you need. Okay, that brings us to today's webinar topic: new features and updates for the beginning of 2021 in our cloud processing software, LiDARMill. In today's webinar, we'll spend a few minutes introducing anyone who is not a current user to the general LiDARMill workflow. We'll really just kind of skim the surface of what the software does overall. So for a more in-depth overview of the process, please check out our website or our YouTube channel. After the overview, we will cover the new features that are part of a beginning of the year upgrade release. These features include an overhauled coordinate reference system wizard, new GCP handling and accuracy reporting, tiled data options, improved documentation, and a new framework at the core of our data calibration. We'll conclude the webinar by revealing an upcoming machine learning-based automated classification pipeline. So let's start with an introduction to LiDARMill, kind of how it works, what are the benefits of using it to process your remotely sensed data. LiDARMill is Phoenix LiDAR's cloud-based automated data processing software. It's a complete workflow that has been simplified as much as possible for the user. LiDARMill processes navigation data to make accurate trajectories. It calibrates and processes LiDAR data plus imagery. It creates accurate geospatial point cloud data and other common derivative products. Each step in the automated pipelines are built to really maximize accuracy and to optimize data quality. There are built-in QC tools and reports that help users ensure that their data meets standard, and also an online data viewer to review your results visually. The primary goal of LiDARMill is to produce the data you need with minimal effort and also reduced risk of error. So because it's highly automated and does not need a tremendous amount of user oversight like traditional data production workflows, LiDARMill will save time and money. Data processing steps are traceable and repeatable, so consistency is another major benefit. Additionally, your results will be available online for anyone in your organization to review, which makes point cloud data access and viewing a rather simple thing. There are 4 main steps to a general LiDARMill project: set up a mission, a NavLab pipeline for trajectory processing, a user pipeline for almost everything that's part of post-processing, and then retrieving and checking your data. The first step is to gather your data and upload it to a LiDARMill project. Data that comes from Phoenix LiDAR systems works seamlessly in the platform, and we're also always working to make third-party data compatible as well. Typically, raw LiDAR range data, raw navigation data, raw imagery, static reference station files, and survey ground points are included in the initial data upload. Also, data from multiple flights can be uploaded into a single mission and processed all together. Trajectory processing is really the first major step in post-processing. The NavLab pipeline will process multiple iterations of your trajectory and present you with the best results. Many of the tedious steps of trajectory processing, like determining refined reference station coordinates or testing GNSS lever arm accuracy, are automatically done for you in this pipeline. So at the end of the NavLab pipeline, you'll have a QC report to verify that everything went smoothly. And also, of course, you'll have a process trajectory to move forward with. Step 3 is to run a spatial fuser pipeline. There's really a lot that's happening during this pipeline. First of all, your raw LiDAR range data gets turned into a geospatial point cloud with color that's been extracted from imagery. The LiDAR cloud can be optimized by systematic foresight corrections and also optionally trajectory-based adjustments determined by our LiDARSnap algorithm. Some data classification can also be performed and data products optionally generated. A detailed report is created and your calibrated data set is imported into our online viewer. Essentially, this is an entire post-processing workflow that's bundled into a single automated pipeline. The final step is really just to review and retrieve the results of your fuser pipeline. It's best to spend a bit of time checking the processing report and visually checking your point cloud in the online viewer before downloading. That way, if anything needs to be adjusted, you can restart your fuser pipeline with some different options selected. From there, you can download your data and move forward to any type of analysis that you need. All right, let's move on to some of the new features that have just been released. Any current LiDARMill users probably noticed the changes that we're about to review were actually rolled out over the past weekend. The most noticeable update is to how projects are set up. A coordinate reference system now gets set for each project right from the start. The CRS is really one of the most critical aspects to get right when you are considering data accuracy. So we built a wizard to guide you through the process and help ensure that an appropriate coordinate reference system is selected. Previously, setting these CRS details were specified as pipeline parameters, and we found that it was kind of easy to make a mistake when there were so many other variables to consider at the same time. So now more emphasis is put on setting the CRS up front, and we've made that a lot easier to do. When we set the coordinate reference system during project configuration, we're essentially telling LiDARMill what CRS uploaded GCPs will use and also what CRS our output products will be based on. So this is kind of a really critical step to focus on. It's possible to go back and edit this after creating a project, but that definitely should be avoided, as any previously processed data will not match future outputs. Another new aspect to the initial project setup is an updated GCP handler. We've built GCP configuration alongside the CRS wizard because the two are tightly connected. Really, the georeference of your project overall depends on setting both of them correctly. Uploading and configuring your GCP should be fairly straightforward in the new interface. You can upload a CSV and then specify what each column contains. There's also a map view that will help you see if the columns are correctly assigned and that the data in those columns work appropriately with the project coordinate reference system that you've just spent some time setting. A major upgrade that we've made to the control point utilization is adding the ability to designate a points type. Now points can be labeled as either control or check. Basically, control points are what is used during data optimization to influence the vertical positioning of your project, while checkpoints are withheld from any of the processing steps and used strictly for verification of results. If all points were checkpoints, then we're left with no reserve survey points for checking data quality per current industry standards. So now users can upload all of their surveyed ground points and choose which to use for either purpose. The project reports that are produced during Spatial Fuser pipelines make accuracy statements based on which points were specified as checkpoints. This improvement in reporting should save users from having to do this statistical analysis of accuracy offline in a GIS or in any other software. You can see in this green snip of a report that checkpoints are highlighted in blue, and the accuracy statistical summary is based off of those checkpoints alone. Shifting gears away from control and back to output data, we have a new option for users to generate tiled results. This is especially useful for large projects where data in a single .laz or .las file would be unmanageably large. So now instead of dealing with, for example, a 20 gigabyte point cloud file, data can be downloaded as gridded tiles of a user specified size. This is really primarily helpful for data management, but also can be useful if you are strictly interested in downloading a subset of your project area. Like if there's one key spot that you want to download first and check, this makes that possible. Users can choose a zip with all tiles, or can use a new map interface to make spatial tile selections and download subsets. All right, let's jump into LiDARMill and check out these features that I have just discussed. So here is our LiDARMill interface. First, I'll go over the project configuration and the project setup. I'll start by adding a new project. Here we will give this project just a generic name. It's worthwhile to keep in mind that LiDARMill can process multiple missions or multiple flights together. So naming this project something that is applicable to your project overall rather than just a specific mission is useful here. Since we felt that the coordinate reference system was such an essential part of the project, we've moved it to be the first thing that you need to address in your processing. So first of all, we will choose a coordinate reference system using our wizard. It's possible that if you've already processed some missions, that the coordinate reference systems you previously used will be available to select again. So these are the 3 different CRS that I used on the example projects that are part of this profile. But if none of these match what your new project needs, then that's where the wizard really comes in handy. So we'll select new coordinate reference system. Then we're presented with a map. This is for selecting the general location of our project. That general location is going to be used by the wizard to make sure that the CRS details that we specify are make sense for the location that we're surveying. So there's a couple of ways to check or to set a project location. We can go into the map and mark it with our mouse, or we can also search for a location here and select it from a list of results. It doesn't need to be extremely precise, but it needs to be in the right general region. Once we have that marked, we'll move on to specifying the details. The first detail that we're asked to consider is what datum we should set. And the button shown here that says show recommended datums is really a filter that will filter the list of available datums based on the location that we've set. So you can see that when I expand this list of recommended datums, it's not an overwhelming list that shows every datum. It's just a list of what our wizard thinks is applicable for the given project location. So we'll select a pretty standard current datum for this project, and then we need to specify what units our project will be using. In this case, let's just choose standard feet and hit next to go to our projection details. We have another filter that is filtering the options based on our what we've specified so far. So in our horizontal coordinate system list, we only have options that are of the datum and units that we've previously set. So in this case, we've narrowed it down to just 4 options. We can assume that this project is using the Oregon-Lambert projection, and then we're left with the height type. So we can choose ellipsoidal, which would be based on the NAD83 datum that we have selected, or we can choose orthometric, And when we select orthometric, we're presented with a list of potential geoid files that are available for the given project location. We can select, let's just say, geoid 12B, and then the wizard knows that that is part of the NavD88 vertical coordinate system. If for some reason the wizard doesn't have a reference to the local coordinate system that you might be using, you can enter a custom string. But in general, you should be able to use this to find the appropriate reference system for your project. Let's actually go back to Datum, because I have some data that I'm going to import in a second and show you, and definitely want it to match. Actually, I can, yeah. Next, I will choose our UTM zone and ellipsoidal heights. So this is a pretty standard coordinate system that I have some sample data for. All right, now that we've got our coordinate reference system specified, we can choose to import ground control points if we have them. So let's say GCP file, and then we're presented with the tool to upload our GCP data. We have a couple of options. We can upload from Dropbox or from a local file. GCPs are usually small text files, so in this case, I'm going to upload locally and choose my GCP file. It's simply a CSV file. And in this dialog, we can specify what each column represents. So we can see in this map view that our points are lost in space. And that's mostly a QC tool that we have to make sure that everything is specified correctly. So the first column is just a label. The second column is our easting. Then we have northing and our elevation values. You can see these are still out in the ocean, so clearly we've done something wrong here. And that's the main benefit of this map, is that we're going to be able to avoid easy mistakes to make, really dramatically impacting our processing. So let's trace this back. I'm confident in these column labels. And if we look at this file, we can see our UTM zone is actually 11. So we've set up this project using a coordinate reference system that doesn't match our GCPs. And that's something that we want to address right from the start. So let's jump back to the wizard. Our location is definitely not the right UTM zone for these coordinates, so we can kind of go back through this. Choose zone 11. And now we've just troubleshooted a really common problem. Our GCPs are in the correct location, as we can tell by this map. So the next thing that we would want to do is go through and decide of these, what do we have here, over 40 GCPs, which ones do we want to utilize for what purpose? Typically, we don't need 40 control points, especially for an area like this. We might want to choose 4 of them or 5 of them just to control our data, and let the others be accuracy verification checkpoints. So let's just choose some well-distributed ones for control. We could say maybe 0.16 and go into our list and change the type to, oh, it already is control, so we can actually change all of our points to checkpoints, and then 0.16, we can make this one control. We can go through and select another, and this is user's discretion which points you want as control and checkpoints, but there are some industry guidelines that you typically should follow. You want to have a significant amount of checkpoints to have defensible accuracy statements. And you also want to have well-distributed control and checkpoints. So you wouldn't want to make all 6 of these control points and the other ones checkpoints. Instead, you want to have everything kind of well-distributed. So 46, we'll make that a control point. And let's just say that one of these is actually a measurement from our reference station, and it's not really applicable to controlling or checking the data. So let's just assume that's 27, and if we want to exclude this from either of those, then we simply set this to unused. And finally, we'll hit next and get a summary of our project details. And then we can submit this to create a new project. The other thing that we saw from the slideshow is that we can download our data in a tile format rather than just one bulk download. That's going to be especially useful for large projects like this project that's over 100 gigabytes of data. It can also be useful for smaller projects. If we set a tile size during the spatial fuser pipeline, then in our list of pipelines, instead of just having the option to download our results, we also have the option to, instead of just downloading our results in the traditional method here, we have the option to use this interface to select tiles. So this zooms us to our project location where we can follow the instructions up at the top and select individual tiles by holding our control key. So let's say we just really wanted data from this specific area. We can download this block without really having to consider the other data. Maybe this is our main QC area. Also, if we're interested in, say, the northern half of our project, we can select the tiles by holding Shift and dragging. Then we can use the window on the left side to download selected tiles or individually download one by one. Another helpful update that we've made is building dedicated LiDARMill support documentation. We have a Git book that's filled with step-by-step instructions and general guidance on parameters and options that you'll encounter during processing. And access points to this documentation have been added at key locations in LiDARMill where users are most likely to want some clarification. So, for example, if you are uncertain about ground control, maybe how to use it in the software, or just want some general guidance on it, you can click on the help button and get direct access to our documentation. One of the more behind the scenes changes that has been made in these new releases is the deployment of the Spatial Explorer 6 core. This is like the backbone of LiDARMill, and it does the heavy lifting. It might not be easily visible to the users, but a lot has changed with this new core. The biggest change that you might notice is that our calibrations are now done in the IMU frame. And this means that foresighting results are really independent of vehicle installation parameters, which will make switching your system between vehicles, especially between vehicles where it's mounted in different orientations, much more straightforward in the future. Another huge upgrade is the new version of LiDARSnap. LiDARSnap version 4 is definitely one of the key components of the new Spatial Explorer core. In it, we've added newly developed methods of modeling the systematic errors and correcting for them, which can yield significantly better foresight calibrations for some scanners. Like in the screenshot, you can see the precision of a Scout 16 dataset was improved about twofold just by using LiDARSnap 4 via the Spatial Explorer 6 core. So this is not a highly visible update to the LiDARMill interface, but it is a significant one with respect to data quality. Okay, another development that we want to share with you is the machine learning classification pipeline that you may have already seen available. We have implemented a totally automated AI-based classifier that uses trained models to fully classify your point cloud data. At the moment, there's a single classifier model available for beta testing that is primarily based off of utility data sets. You can see that this list of features on the slide, and anything in it highlighted will be something that the current model tries to identify. Eventually, it's possible to add more trained models that are tailored for specific types of data sets, but we decided to start with a common type that has really a variety of complex features. Let's take a look at one transmission corridor that has gone through this machine learning pipeline. Here's one of our validation data sets that we've entirely processed with machine learning. It's colored right now. Is influenced by the classification. So when you see purple versus pink versus brown and green, these are all representing different classifications. The really exciting thing about this is just how detailed we're able to get on the utility infrastructure. You can see that we've got two types of wires and also the connectors and the insulators and the tower all classified. There's also some vegetation underneath the tower that is correctly classified as vegetation rather than as part of the tower. I guess to kind of convey the usefulness of this, in a typical classified by hand workflow, I would estimate that each one of these towers takes at a minimum 5 minutes to classify, and that's just to differentiate, wire from tower versus insulator, and make sure that all of the details are classified. So let's just say 5 minutes per tower, and then on this entire data set, we probably have at a minimum like 40 towers. So if we can get a good head start on classifying our data set by using this, we have the potential to save a tremendous amount of time. It's not just the utility infrastructure that's being classified, because we realize that there's a lot more that goes into analysis than just simply having these lines or these wires and towers identified. We also are classifying buildings, differentiating from veg, finding fences, and finding vehicles. So kind of the most common above ground types of data are really what we're trying to identify here. So this is something that we're super excited about and also actively developing. If you'd like to learn more about LiDARMill in general, please visit our website, phoenixlidar.com/LiDARMill. You can learn more there and also request a trial. So thank you for your attention. I think I'll open it up to question and answer. If anyone has anything.
All right, thank you, Conrad. We do have our Chief Technology Officer here, Dr. Ben Adler, who will answer a couple of the questions that we have logged on. Ben, are you there?
Yep, I'm here. Hi, everyone. Thank you very much, Conrad, for the presentation. All right, so yeah, we've gotten a couple questions, and keep sending them our way. Oh boy, let me start with some earlier ones. One question was which coordinate systems we support, and essentially what we implemented is the EPSG database. If there is anything that you need that isn't supported yet or doesn't show up there, feel free to shoot us a message to support@lidarmill.com or within the LiDARMill UI. Usually there's ways of implementing custom or even local coordinate systems. Yeah, we're quite flexible with that. So there's ways of specifying custom coordinate systems. Then there's one question on whether we support third-party systems, and I think Conrad briefly touched on that. The answer is always it depends. There's some questions with data formats. There's sometimes questions with how those systems timestamp data, if it's software timestamping, or like if it's accurate enough that we can get to what people are looking for. So it really depends on the system. So usually you'd have to send in a sample data set, and then we can see if we can make it work. Another question was about mobile data acquisition or mobile LiDAR processing. LiDARMill is really made for the aerial mapping application. We definitely can process trajectories, and we can also process LiDAR, but the strip adjustment and those algorithms are really tailored towards aerial acquisition. So it's not like it doesn't work, but we don't really support it. Then Oh, one question was on reference stationless data processing. So what if you don't have a reference station for whatever reason? Maybe there's some customers that scan corridors, and depending on the length, it can be quite a hassle to set up reference stations. We do support reference station-less processing. There's some constraints on satellite tracking. So this wouldn't be for mobile, but really only for aerial, because you need good satellite tracking for that. But it is supported, and the accuracy is about 3 to 7 centimeters in positioning. So that's slightly worse than having your own reference station, but for many projects, that's still within the tolerance. One more question. If LiDARMill handles the thermal solution that we offer, yes, it does. What happens then is that you get a point cloud that has the raw thermal values so they're drift corrected, but other than that, they're raw in the point cloud's NIR channel. So you can measure temperatures in the point cloud. And it does not replace either the laser intensity, which is stored in the reflectance channel, and it does not overwrite the RGB values either. So you can have all of that in one point cloud. What else do we have? Here's a UAV question. Can the new FreeFly Astro handle your payloads? I believe that's a 1.5 kilogram payload UAV. So the smaller systems, yes. Of course, then when you get to the Rangers, then no, that's a bit too heavy. So some of them is the answer. Let's see. Then there is, what are the offsets shown below the GCP labels? I believe that refers to the map, where you could see like the GCP name as well as the offset to the, well, I guess that was the question, the offset to the ground model. So that's another thing we do to indicate, like to give you an idea if the height is right. Because in the past we've seen that people had GCPs that were using a geoid, but they didn't select the geoid. And then if you see those 30-meter offsets, that's a good clue that you've missed something in terms of height. And that's why we're showing that. The height model that we use isn't always that accurate. So if it says it's off by 2 meters, then that's usually fine, because the model just has those errors. But it really helps in getting some confidence in your in the vertical part of your CRS. Yeah, there was one question, and that's actually been a request in the past, that you'd like us to visualize reference stations in Poetry, so in the cloud viewer that we use, and we implemented that, and should be available since since this Monday, essentially. You do have to, like, if you want to see it for older projects, you do have to rerun the pipeline, but then the reference station is going to show up. So the marker, the ARP, as well as the L1 phase center, because sometimes people are confused as to what they should specify, and that really helps in visualizing it, understanding it, for those that haven't done it for forever, and making sure that you get this right. Then there was a question if the point cloud classification is using ASPRS classes, and the answer is yes, it does. Sometimes it's actually quite amazing. So we're looking at the classification results, and we found that it's getting to the point where we can't decide what a point should be. For example, there's I think the ASPRS classification has vegetation, obviously, and it has fences. And we realized that the model can struggle if there is fences made of vegetation. And that goes to show how far it's come, right? When that's the problem. But yes, the classes do match the ASPRS standard. I don't know if I'm dragging this out too long here. There's one more question on whether we can classify LAS files only. So if you don't upload raw data when we process the point cloud, but maybe you already have a LAS file, and the answer is yes. You can upload a LAS file and start just the AI classification pipeline. Right now, as Conrad mentioned, it's kind of in an early state, but for now it's a trial. It's free, and we'll see where this goes. And of course, we're interested very much in feedback. So please do run some pipelines and let us know what you're seeing, how it's useful, maybe where it's failing, and then we can see how we can make this even more useful. Let's see if there's anything else. I think that's about it. Lido, did I miss something?
Let's see.
Oh, here's one. Sorry. How big of a LiDAR dataset will LiDARMill handle?
Here we go.
Really, I don't think we've hit a limit yet. I know of datasets that are like in the 400 gigabyte range. So uploading that with a browser is rarely fun. That's why we have this Dropbox import, because we found that many people just keep their data in Dropbox, and then importing from Dropbox to LiDARMill is usually much faster than using the browser. So the browser should resume uploads if you close the tab by mistake and all that. But in the end, it'll never be as robust as just downloading this from Dropbox. But once it's imported, yeah, there really is no limit. Yeah, and we do have people uploading helicopter and fixed wing data. That was the question. So a couple billions of points is it'll take longer, but it does work. There's one more. Is the point cloud colorization a new feature? No, it's not. It's been there for a while. We actually use LiDARMill to calibrate our systems before we ship them. So camera calibration and colorization has been there for a while. There may be some advanced options that we added, or some admin only options for like, because we're trying to keep LiDARMill as simple as possible and not have like 100 buttons in there. But the colorization, if you do upload imagery, then you've been able to colorize for a while. Oh, there's another one. If we support manual classification, not in LiDARMill. So that's, and I don't think we're going to go there anytime soon, because that's a very interactive feature, and I'm not sure how much fun that's going to be in the browser. If you do manual classification, it's really every click, every keystroke that has to be super efficient, and things have to be really quick. Otherwise, you'll die trying. And it's just, yeah, I'm not quite sure if the web browser experience is there yet. One question is, does the data need to be noise-free, or will the machine learning process clean noisy data as well? Yes and no. There's very different kinds of noises. If there's the occasional sun noise, or you're scanning, I don't know, a mirror or water, and there's a couple noise points, that works. If there is systematic noise, for whatever reason, or maybe there's MTA noise with the faster scanners, then that has to be pre-denoised. But yeah, light amounts of noise are not a problem. But if it gets heavier, then there needs to be noise filtering as a pre-step.
All right, and that should cover all the questions that we had. Thank you very much, Conrad, and thank you very much, Ben. If you want to see a replay of this webinar, it will be available on our website and then in the news section within the week. And there'll be a link there to click to request access to it. And so thank you very much, all. We look forward to seeing you at our next webinar for February 2021. And everyone, thank you very much. Have a good day.